They make errors. Now, very good. Okay, so they make honest errors. Okay, they're not intentionally trying to rip you off, but they somehow make mistakes during the construction phase of the house. Go ahead.
They would build the house to fit the specific purpose and their specifications of how they built it, but when an engineer comes in to check it, they may find that, well, this isn't the same as the earthquake, or
Well, that part is already handled by the time the engineer.
not the engineer, but the code inspector.
Okay. Okay, go ahead.
Sometimes you need a fresh pair of eyes to see something that you might overlook because you're so focused on it. You know the details of what goes on. Fresh pair of eyes can see something from a different perspective.
Okay, now, so that's a really good, addition to what you just said. Okay, go ahead. Oh, what he just said. Okay.
They're more biased to their own work, so that they're like, when they make a decision, it's like they're more biased.
Exactly. So these three, ideas, together explains exactly why we don't want developers in an information system to do their own testing. Because if they made an honest error and forgot or misunderstood or understood something incorrectly during the coding, what makes you think during the testing they would make a different and correct interpretation of the same part of the specification? Go ahead.
Well, the client may see, when they first developed it, the client may see something one way, and then after it's been developed, may say, okay, that's not exactly what I wanted.
Well, that's not a problem from the developer's perspective or the tester's perspective. That's the problem that you have to take up with the systems analyst, which is the architect. Because once the specification is released, once you have a blueprint that is already approved by the engineer, that it is fulfilling all the safety requirements, and is signed off by the client, it becomes a contract. Okay, that is exactly what we are going to build. The testers are not really testing whether it is still satisfactory to the client. The tester is testing the system against the blueprint itself. So if the client has a problem with the blueprint, it's a contract issue. They have to take it up with the systems analyst because that's their point of contact in terms of the system itself. Okay, but the main problem here is if a developer, or the group of developers made a mistake during the coding part of it, they will also make the same mistake during the testing phase of exactly the same thing. Okay, or very likely they will make the same mistake. If they overlook something when they're coding, they will overlook exactly the same thing when they're testing it. Yep.
What about critical vulnerabilities and exposure to vulnerabilities?
You mean from the security standpoint? That's most of the time it's audited by someone external to the entire team. There are people who specialize in security audits and that sort of thing. Special tools and special skill set. This is really just checking everything is to specification. If the system specification says someone should be locked out of a system after 3 consecutive attempts, 3 consecutive failed attempts to log in, this is what the test is about. It's not about whether 3 is a good number. It's about whether it is 3 times or not, because 3 is what is specified in the specification. Okay. Yep. Go ahead.
When creating a program, as a tester, is it best to have your coworker test it for you, or like your brother who doesn't know anything at all, just to see if they can crash the system?
Okay, that's a good question. What you're asking is, should we use we call this a white box, black box testing. The black box method, it simply means I don't care what is in the box, but as long as I have a specification of what the box is supposed to do, I'm going to use that method to test the box for, is it doing everything it's supposed to do? Okay, it can be magical, it can be mechanical, it can be electronic inside the box. I don't care what it is in the box, but as long as if I give it this stimulus, it gives me this response according to specification. If it passes all the tests, it's okay. Now, open box or white box testing is the opposite, where you open up the box and you look at the mechanisms in the box and ask, okay, are these mechanisms supposed to implement what is specified on this list? So there's a black box versus white box approach when it comes to testing, and most companies do black box testing instead of white box testing.
It's like Java.
Hmm?
Like Java.
Like Java? Why do you think that?
Well, the last release of Java, they found, before the last release, they found Israeli vulnerability, and then they patched it, and they found another, like within the span of a week and a half.
Yeah, well, that is not atypical. In software development, what you just mentioned.
That's not atypical of Java.
Well, especially now that Oracle owns it.
Yeah.
All right. Okay, so we are done now with developers and algorithms. We are. Okay, I'll just kind of go on to these two Wikipedia pages, just for a really short period of time. This explains what is a software developer. A software developer is a person concerned with the facets of software development, which itself is also a linked process. Their work includes researching, designing, implementing, and testing software. And I can tell you, the test. It's not separating implementation from testing, but in reality, there are people specialized, in testing, special tools and also special skill set for testing software. How would you test software, by the way? I can give you something simple, okay? Something really, really simple, and you tell me how you will test that program. Mousepad. Mousepad here is really the same as Notepad in Windows. How do you test Notepad to make sure that it is working the way it's supposed to?
Start typing.
Start typing, okay. And, okay, go ahead.
Use all the functions, all the menus, all the options.
All right, so we're getting better. We use all the different functions, all the different menu items. Yeah.
Try to interact with the program, see if it will save your document, see if you can open a document once you have saved it, and see if it can open other documents.
Okay.
From other sources possible.
All right. Will that catch problems like, I have to type up to 65,536 characters, and the problem only occurs if I try to delete the last character at that point. Okay? Now, I take that number, 65,536, for a particular reason. It's 2 to the power of 16. Okay? So there are, well, used to be, so they might have leftover variables that are still 16-bit. Okay? So that means testing a program is not really quite as easy as we think, because there are things that the tester may not think about, especially on an open-ended program like this, because this is a really open-ended program. There are certain bugs that can happen only if you follow a particular sequence of operations. And the sequence may not even look conspicuous. Okay, it can be you type 5 lines of code, 5 lines of text, remove the first one, and then you type something in the second one, select something else on the screen, and then replace it with paste in some other additional text, and then the problem happens. Okay, so in other words, a lot of times it is not possible for a tester to come up with all the different tests that you need to qualify the program and say, okay, I think it is okay now. Many times, you would release, software or programs to the field because the tester has tested everything that he or she or the entire team thinks is possible, and yet there are still additional problems. So what happens is now, people will report the bugs and say, okay, I follow this particular sequence and this problem happens. Okay. And that particular bug or reported bug will now become a part of the history of the software. And then we have a process called regression, regression testing, which means you have to test the software not only on the usual test pattern, but everything that was wrong with it before, you have to test for those problems too whenever you retest the software. Okay, so you basically gradually increase the test cases of a particular program, based on field observation and bug reports. All right, that's that. Algorithm as defined in Wikipedia. In mathematics, in computer science, an algorithm is a step-by-step procedure for calculation. So that really is the definition of an algorithm. Okay. It's just a method, a procedure for doing certain things. Algorithms are used for calculation, data processing, and automated reasoning. Just about everything that a computer does, there's an algorithm behind it. Right. So what we'll do is now we are moving on to topic 2 and really get started with programming concepts. All right. So we'll get started with the concept of, first of all, we'll talk about variables, and then we'll talk about assignments and expressions in general. So we will use an example. I really need to update my example because it's really kind of dated by today's standard. So we'll use the example because most people still understand what it means. Okay, so we'll start with a mundane task that you want to use a computer to help you, or this is something that you do by hand. Okay, let's just say that we are doing this manually by hand. You get your credit card bill, from your mailbox. And let's just say that the balance is X amount. You want to write a check, pay the credit card company, exactly that amount because you don't want to accrue, interest and stuff like that. And then you want to deduct the same amount from your savings account, because you're keeping track of how much money you have left in your bank. And last of all, the last item here is to keep track of how much money you have spent through that particular credit card. Now this is of course this is all assuming that we are not doing type of online banking. Okay, this is back in the good old days where we cannot do online banking. So there's no way for you to pay bills online and know your balance, just by logging to a website and know your balance. So you have to keep track of your own balance, yourself, using a little notebook. So does everybody understand the example? What I'm trying to do here? Okay. So the first concept we want to know is what a variable is. A variable, as the name implies, is an object that can hold a value, and the value can change over time, and that's why we call it variable. And more formally, we'll talk about the attributes of a variable. First of all, each variable has a name, because we don't want to say, oh, this variable, that variable, or that variable. Okay. We want the variables to have names so that the name itself will uniquely identify which variable we are talking about. The type part we will kind of skip for now. And each variable has a value. The value is kind of its content. Some people will also say the value is a state. A variable has a state, and the state is the value. All right, so let's connect these concepts to our example. In this case, we'll look at all the variables that we have. In this case, X is a variable. Okay, let me go back to the previous slide. What is X? X is the balance of the credit card bill that you just received. Do you get the same amount? Do you get the same, not balance, but do you get the same, is it called balance? It is balance. Do you get the same balance, on every single month? No, it changes, right? So if I just say that X represents the balance of the current credit card bill, we don't know what it is. It changes from month to month, and that's why it's a variable. Okay. So, but we have other variables too. The other variable that we have, one is called available funds. It's basically the